DDR3 Sdram.
In computing, Ddr3 Sdram, an abbreviation for double data rate type 3 synchronous dynamic random access memory, is a modern type of dynamic random access memory with a high bandwidth interface, and has been in use since 2007. It is the higher speed successor to DDR and DDR2 and predecessor to DDR4 synchronous dynamic random access memory chips. Ddr3 Sdram is neither forward nor backward compatible with any earlier type of random access memory because of different signaling voltages, timings, and other factors. Ddr3 is a DRAM interface specification. The actual DRAM arrays that store the data are similar to earlier types, with similar performance. The primary benefit of Ddr3 Sdram over its immediate predecessor, DDR2 Sdram, is its ability to transfer data at twice the rate, 8 times the speed of its internal memory arrays, enabling higher bandwidth or peak data rates. With 2 transfers per cycle of a quadrupled clock signal, a 64-bit wide DDR3 module may achieve a transfer rate of up to 64 times the memory clock speed MHz, in megabytes per second, megabyte per second. With data being transferred 64 bits at a time per memory module, Ddr3 Sdram gives a transfer rate of memory clock rate, x4, for bus clock multiplier, x2, for data rate, x64, number of bits transferred, /8, number of bits byte. Thus with a memory clock frequency of 100 MHz, Ddr3 Sdram gives a maximum transfer rate of 6400 megabytes per second. In addition, the Ddr3 standard permits DRAM chip capacities of up to 8-bit.
Overview.
Compared to DDR2 memory, Ddr3 memory uses 30% less power. This reduction comes from the difference in supply voltages, 1.8 V or 2.5 V for DDR2, and 1.5 V for DDR3. The 1.5 V supply voltage works well with the 90-nanometer fabrication technology used in the original Ddr3 chips. Some manufacturers further propose using dual-gate transistors to reduce leakage of current. According to JEDEC, 1.575 volts should be considered the absolute maximum when memory stability is the foremost consideration, such as in servers or other mission-critical devices. In addition, JEDEC states that memory modules must withstand up to 1.975 volts before incurring permanent damage, although they are not required to function correctly at that level. Another benefit is its prefetch buffer, which is 8 burst deep. In contrast, the prefetch buffer of DDR2 is 4 burst deep, and the prefetch buffer of DDR is 2 burst deep. This advantage is an enabling technology in Ddr3's transfer speed. Ddr3 modules can transfer data at a rate of 800 to 2133 MTS using both rising and falling edges of a 400 to 1066 MHz I/O clock. Sometimes, a vendor may misleadingly advertise the I/O clock rate by labeling the MTS as megahertz. The mount S is normally twice that of megahertz by double sampling, one on the rising clock edge, and the other, on the falling. In comparison, DDR2's current range of data transfer rates is 400 to 1066 MTS using a 200 to 533 MHz I/O clock, and DDR's range is 200 to 400 MTS based on a 100 to 200 MHz I/O clock. High-performance graphics was an initial driver of such bandwidth requirements, where high-bandwidth data transfer between frame buffers is required. Ddr3 does use the same electric signaling standard as DDR and DDR2, stub series terminated logic, albeit at different timings and voltages. Specifically, Ddr3 uses SSTL15. Ddr3 prototypes were announced in early 2005. Products in the form of motherboards appeared on the markets in June 2007 based on Intel's P35 Bear Lake chipset with DIMMs at bandwidths up to DDR3-1600, PC3-12800. The Intel Core i7, released in November 2008, connects directly to memory rather than via a chipset. The Core i7 supports only DDR3. AMD's first socket AM3 Phenom 2X4 processors, released in February 2009, were their first to support DDR3. DDR3 DIMMs have 240 pins and are electrically incompatible with DDR2. A key notch, located differently in DDR2 and DDR3 DIMMs, prevents accidentally interchanging them. Not only are they keyed differently, but DDR2 has rounded notches on the side and the DDR3 modules have square notches on the side. DDR3 SODIMMs have 204 pins. GDDR3 memory, sometimes incorrectly referred to as DDR3, because of its similar name, is an entirely different technology, as it is designed for use in graphics cards and is based on DDR2 SDRAM.
Latencies.
While the typical latencies for a JEDEC DDR2 device were 5-5-5-15, some standard latencies for JEDEC DDR3 devices include 7-7-7-20 for DDR3-1066 and 8-8-8-24 for DDR3-1333. DDR3 latencies are numerically higher because the I/O bus clock cycles by which they are measured are shorter. The actual time interval is similar to DDR2 latencies, around 10 nanoseconds. There is some improvement because DDR3 generally uses more recent manufacturing processes, but this is not directly caused by the change to DDR3. As with earlier memory generations, faster DDR3 memory became available after the release of the initial versions. DDR3-2000 memory with 9-9-9-28 latency, 9 nanoseconds, was available in time to coincide with the Intel Core i7 release. CAS latency of 9 at 1000 MHz, DDR3-2000, is 9 nanoseconds, while CAS latency of 7 at 667 MHz, DDR3-1333, is 10.5 nanoseconds. CAS/frequency, megahertz x 1000 equals XNS. Example: 7/667 closing round bracket times 1000 equals 10.49475 nanoseconds.
Power consumption.
Power consumption of individual SDRAM chips, or, by extension, DIMMs, varies based on many factors, including speed, type of usage, voltage, etc. Dell's Power Advisor calculates that 4 GB ECC DDR1333R DIMMs use about 4 W each. By contrast, a more modern mainstream desktop-oriented Part 8 GB, DDR3/1600 DIMM, is rated at 2.58 W, despite being significantly faster.
Extensions. XMP.
Intel Corporation officially introduced the Extreme Memory Profile (XMP) specification on March 23, 2007 to enable enthusiast performance extensions to the traditional JEDEC SPD specifications for DDR3 SDRAM.
DDR3L and DDR3U.
The DDR3L, DDR3 low voltage, standard is an addendum to the JESD 79-3 DDR3 memory device standard specifying low-voltage devices. The DDR3L standard is 1.35V and has the label PC3L for its modules. Examples include DDR3L800, DDR3L1066, DDR3L1333, and DDR3L1600. The DDR3U standard is 1.25V and has the label PC3U for its modules. On July 26, 2010, JEDEC Solid State Technology Association announced the publication of JEDEC DDR3L.
DDR3 Serial Presence Detect.
Release 4 of the DDR3 Serial Presence Detect (SPD) document, SPD 4010211, adds support for load reduction DIMMs and also for 16B SODIMMs and 32B SODIMMs. On September 1, 2011, JEDEC Solid State Technology Association announced the publication of Release 4 of the DDR3 Serial Presence Detect (SPD) document.
Modules. JEDEC Standard Modules.
Optional. CL, clock cycles between sending a column address to the memory and the beginning of the data in response. TRCD, clock cycles between row activate and reads writes. TRP, clock cycles between row precharge and activate. Fractional frequencies are normally rounded down, but rounding up to 667 is common because of the exact number being 666 2/3 and rounding to the nearest whole number. Some manufacturers also round to a certain precision or round up instead. For example, PC3-10666 memory could be listed as PC3-10600 or PC3-10700. Note: all items listed above are specified by JEDEC as JESD 79-3D. All RAM data rates in between or above these listed specifications are not standardized by JEDEC, often they are simply manufacturer optimizations using higher tolerance or overvoltage chips. Of these non-standard specifications, the highest reported speed reached was equivalent to DDR3-2544, as of May 2010. DDR3XXX denotes data transfer rate, and describes raw DDR chips, whereas PC3XXXX denotes theoretical bandwidth, with the last two digits truncated, and is used to describe assembled DIMMs. Bandwidth is calculated by taking transfers per second and multiplying by 8. This is because DDR3 memory modules transfer data on a bus that is 64 data bits wide, and since a byte comprises 8 bits, this equates to 8 bytes of data per transfer. In addition to bandwidth and capacity variance, modules can optionally implement ECC, which is an extra data byte lane used for correcting minor errors and detecting major errors for better reliability. Modules with ECC are identified by an additional ECC or E in their designation. For example, PC3-6400 ECC, or PC3-8500E, be registered, which improves signal integrity, and hence potentially clock rates and physical slot capacity, by electrically buffering the signals with a register, at a cost of an extra clock of increased latency. Those modules are identified by an additional R in their designation, whereas non-registered, aka unbuffered RAM may be identified by an additional U in the designation. PC3-6400R is a registered PC3-6400 module, and PC3-6400R ECC is the same module with ECC, be fully buffered modules, which are designated by F or FB and do not have the same notch position as other classes. Fully buffered modules cannot be used with motherboards that are made for registered modules, and the different notch position physically prevents their insertion.
Feature summary.
Introduction of asynchronous reset pin, support of system-level flight time compensation, on DIMM mirror-friendly DRAM pinout, introduction of CWL, CAS write latency, per clock bin, on DIO calibration engine, read and write calibration, fly-by-command address control bus with on-DIMM termination, high-precision calibration resistors, are not backwards compatible. DDR3 modules do not fit into DDR2 sockets. Forcing them can damage the DIMM and or the motherboard. Higher bandwidth performance, up to 2133 MTS standardized, slightly improved latencies, as measured in nanoseconds, higher performance at low power, longer battery life in laptops, enhanced low-power features.
Development and market penetration.
In May 2005, Daisy Roden, chairman of the JEDEC committee responsible for creating the DDR3 standard, stated that DDR3 had been under development for about 3 years. DDR3 was launched in 2007, but sales were not expected to overtake DDR2 until the end of 2009, or possibly early 2010, according to Intel strategist Carlos Weisenberg, speaking during the early part of their rollout in August 2008. The same timescale for market penetration had been stated by market intelligence company Ddr3 Exchange over a year earlier in April 2007, and by Dacey Roden in 2005. The primary driving force behind the increased usage of DDR3 has been new Core i7 processors from Intel and Phenom 2 processors from AMD, both of which have internal memory controllers. The latter recommends DDR3, the former requires it. IDC stated in January 2009 that DDR3 sales will account for 29% of the total DRAM units sold in 2009, rising to 72% by 2011.
Successor.
JEDEC's planned successor to DDR3 is DDR4, whose standard is currently in development. The primary benefits of DDR4 compared to DDR3 include a higher range of clock frequencies and data transfer rates and significantly lower voltage. Some manufacturers have already demonstrated DDR4 chips for testing purposes.